So right now, all of the inputs of the LDR are on, meaning that it gives an output. That's why the priority selector detects that light sensor has reached a maximum value, because it compares its value to the set value, which is in the memory, and the memory was set to number 70111. So if the light reaches a value greater or equal to number 7, then it gives an output. That's why the priority selector gives an output 1. If I can just block this, you can see if it goes to a lower value than 7, then the output goes off. You can lift it, then it goes high. So what happens if both of the inputs are on? What happens if I set pin number 2 on, meaning that the priority selector will have both of the inputs on? Let's check what happens. Orange LED, green LED, then goes off like that. That means that if I turn this on, then a trigger is set, an interrupt signal is set to the decision making part of the circuit, which arranges its output, which one goes first and for how long, and then the next output. And that's what you're going to do today. So yeah. Hello guys, welcome back to Tronic Zenergy. So today we have combined all of the circuits that we have been doing from episode 1 to episode 4. Episode 1 we started off with the memory, episode 2 we went with the priority selector, 3 we made the light sensor, and I think episode 4 is where we did the interrupt. We added the interrupt circuit to the brain. So today I've actually connected all of those different parts together for us to see what the brain can do as for now, because the brain is going to be bigger. Actually, right now it only has one sensor, which is the light sensor. I want it to have, I think, maybe 4 more sensors, because I want it to have a light sensor, sound sensor. We have proximity sensor, no light sensor, we already have it. So light, so temperature, proximity, sound, and maybe motion sensor, and I think we'll be through. So right now, as you can see, it only has one sensor, which is the light sensor. Probably next time we are going to add proximity sensor, and we are going to go on like that. So today we have combined all of the circuits that we have been doing. We have the light sensor right here. We have the memory module right here, which has an AND gate and an OR gate. I'm going to explain why they are there. We have the priority selector right here. We have the decision making circuit. So this all is the priority selector, and right here beside the priority selector we have the interrupt. So this is the interrupt. This is what we did last time. So I'm going to start here. We're going to go step by step for you to understand what is really happening to the circuit. So right here we have the light sensor. So this is how the brain can perceive its environment basing on light. So right here we have the LDR, which is the light dependent resistor, which releases or allows more voltage, or allows more current to go through it from the power supply right here to the other part of the circuit if more light falls into the sensor on top here. You can see this top part. So if more light falls there, then the sensor has the other circuit contains 4 stages, of which it records light. So we have the lower stage up to the high point, or high light intensity point. So this is the LED that shows the last stage has been met. So right here from the output of those LM358, which are the comparator ICs I'm using, the light sensor, they all come into the AND gate. So this AND gate compares the value that is from the sensor and from the memory. So the memory right now I've set it to number 7. If you can see 0111, so that's binary for number 7. That's what I've set the memory to have. So if this value from the sensor is equal to 7 or greater than 7, then it's going to give an output from the AND gate. The output from the AND gate enters this OR gate. So the OR gate is only a 2-input OR gate. So the first condition, the first input of the OR gate is from the AND gate. So it checks if these inputs have reached 7. The other input checks if this input is greater than 7. So greater than 7 means that this last LED is on. So if this last LED is on, or this AND gate records that these 3 inputs, or these LEDs from 0 to number 3 are on, meaning that it's aligned with the memory, which is set to number 7, then it's going to give an output. So the OR gate checks if either the number which is gotten from the sensor is 7 or greater than 7, then it's going to give an output. That output comes and enters the priority selector. So it enters pin number 1 of the priority selector. Pin number 2, I'm going to do it manually for now. Because we don't have any other input. We only have one input, which is from the sensor. Next time, I'm going to add proximity sensor, which will actually be pin number 2. So I'm not going to be pressing. It will all be automated. So the system will be doing its own job according to how it senses its environment. So once it has entered the priority selector checks if either of which input is on. If A is on, then output goes to A, time goes to A. If B is on, then the time goes to B, or the output changes to B only. If both of the inputs are on, now when both of the inputs are on, a trigger is set by this trigger from this circuit that we did last time. Contains 74 LS07 Schmitt trigger. We have the RC circuit right beside it. We have the 10K resistor, 1K, and 1 microfarad capacitor. And I explained, I really hope you understood how the trigger system works. So we called it interrupt. So this is the interrupt of the circuit. So once it detects both of the inputs are on, then the AND gate, which checks A and B, gives an output. That output comes and powers this circuit. Once this circuit is powered, it's going to trigger, it's going to give a pulse. That pulse triggers this monostable mode right here, which then triggers an astable mode in this top part, which powers the whole of this system on top. So once it has powered this system, now the decision starts being done. Because the 2 inputs are on, so the CPU arranges or knows which input should be given more priority than the other one, and by how long. Because also the time can be varied. We can vary the time using these two 10K port meters right here. So this is the port meter for LED, the output 1, which is light sensor, and this is a port meter for output 2, which I'm going to be setting manually. But next time we've said we are going to use the proximity sensor, which is going to be pin number 2. So next time we are not going to need this dip switch. Okay, yeah. So once the 2 inputs are on, the decision making circuit is on. The brain arranges its output according to which one is more important than the other one. Then once all of the inputs have been given time, they all turn on according to the arrangement, and then they turn off, and then the circuit goes back to its initial state to check the next condition. So that's how the circuit operates. Yeah, so from the sensor, memory, comparison of the outputs of the memory to the priority selector, from the priority selector to the interrupt, then from the interrupt to the decision making part of the circuit, which arranges its output according to how you have set your circuit. So let me just demonstrate it. So yeah, just put it on like that. So right now you can see you can see the outputs from the light sensor are all on. So all 4 stages have been met. From there we have the clock which blinks like that. That's the NF55 in A stable mode, the clock of the memory circuit. We have the output which is on. So orange LED is on, as you can see in that top part right there. I hope you can see the orange LED is on. So if I just place my hand on top of this sensor, I want the LEDs to turn off up to this point. So just turn it again. You can see both of those two first LEDs are off, and then the output goes off because it has not reached 7. If I just turn it slowly, you can see now it's 0111, and that's what the memory has. So the output is going to be high. If I just leave it, the output will still remain to be high because it's greater than 7. Yeah, that's how the comparison circuit operates and gives an output to the priority selector. Now let's just leave that like that. If I can just turn on pin number 2, that means both of the inputs of the priority selector are on. Let's see what happens. Then orange LED, then green LED, then it goes off. Let's do that again. So both of the inputs are on right now. Light sensor is on, so input A is on. So input B, we turn it on, and let's see. Orange LED stays on for a period of time, then green, then it goes off like that. So when I put this on, the priority selector detects that two inputs are on. Those two, that configuration gives or sets a request to the interrupt, which sends a trigger to this NE55 monostable mode, which triggers the decision making part of the circuit to decide how to arrange its output and for how long which output is given, the time duration in how the outputs are given. So that's basically what I wanted you to see today. I really hope you've understood how now the brain will be operating. Now if I can add another sensor going to do the same thing, it's going to come and it's going to be input 2. Once it has reached the threshold of number 7, then it's going to trigger, and if both of the inputs are on, then the circuit will be deciding how to arrange its output. So thank you very much guys for watching. Please subscribe to Tronic Zenergy, and I hope to see you next time. Goodbye.